But first, I'd like to give you a little background about this project. Uh, when we started working on this project for the National Archives, we were faced with building a workflow to manage the scanning, georeferencing, metadata creation, and publication of historical aerial photos that spanned several years throughout New Mexico. We decided to create an online application to handle this workflow, among which we would need a way to achieve online georeferencing. As you can see, we achieved this workflow, but we did so by first creating a georeferencing API that could handle all of the georeferencing aspects of the web application. This online georeferencing API also helps to solve the problem of limited personnel by allowing the public to log in using their Gmail or Orchid ID accounts, or by creating a local account with any email address of their choice. Then anyone interested in donating their time could help the project by georeferencing imagery, and any problems with the quality could be handled by an admin user during the QC process. Today, we're not going to be demonstrating the application you see here that uses the API, but instead we're going to be demonstrating the API itself. The API can be rather complex to explain, so after some thought, we decided to create a video that will better describe the processes and methods of the API. This video is not yet public. You guys are the first to see it, and we'd be happy to answer any questions you have at the end. And thank you once again, and I hope you enjoy what we've put together for you.
So I'm gonna share the start the video. Let me know if you guys don't hear or any issues with that.
Hello, my name is Hayes Barrett. I'm the lead developer at the Earth Data Analysis Center at the University of New Mexico. And I'm really looking forward to showing you all today what the georeferencing API can do. But before I do, I'd like to talk a little bit about the grant and project that led to this development. The API is part of a larger 3-year grant from the National Historical Publications and Records Commission of the National Archives and Records Administration. The purpose of this grant is to scan, georeference, create metadata, index, archive, and make web accessible a portion of the 1934 to 1987 historical aerial photo collection, which covers areas across the state of New Mexico. The project is managed by Dr. Zhang. The scanning and georeferencing team is led by Sandeep Talasala and Lisa Sinclair. And our development team is made up of Tyler Eshelman and myself. It should be noted that both the scanning and georeferencing is contributed to by several students and volunteers, all of which we are very thankful for. What is an API? An API, or an Application Programming Interface, is basically an intermediary that allows an application or a script to access remote resources via the internet on a server or on a network. Before I talk about how the API works, I'd first like to talk about the problems that the API is meant to solve. The API was built for this project to solve 2 specific problems. First, how can we reduce the complexity of managing the scanning, georeferencing, metadata creation, and catalog ingest for so many files across so many projects? This would be much easier if we had a simple API that we could wrap the application around. The application could manage the metadata creation, the georeferencing, the QA/QC, the data ingest for online publication, and it could all be managed under one simple web application. The second problem is, how can we georeference such substantial amounts of data with limited personnel? This would be possible if we allowed public access to georeferencing capabilities. This approach would allow teachers, students, or anyone interested in georeferencing to contribute to the project, and any issues with public georeferencing quality can be addressed in the QA/QC workflow. There are also several secondary benefits to having this software decentralized. One that we discovered during the COVID-19 pandemic. Users could continue georeferencing and processing data from anywhere in the world without any need of special software. As long as they had internet access and they had a web browser, a user could log in while working from home and continue georeferencing as normal. Another use of the API is in environments such as machine learning services, where applications and dependencies can be very restricted. If a project that required georeferencing existed in such an environment, the API could be used to do georeferencing using simple web requests. Okay, so now that we've talked about some of the use cases of the API, I'd like to explain exactly how the API works. Now, there are multiple ways of using the API. The first is an interactive approach, using a stream of communication back and forth between the end user and the API, with the result being a geo-enabled image ready for download. The second is a single one-step process, where the user sends a list of GCPs and a non-geo-enabled image, and a warp geo-enabled image is returned. First, let's talk about the interactive methods of the API. Interactive mode begins with a simple file upload. This is a standard HTTP form upload using the POST method. The file needs to be a raster of type PNG, JPEG, TIFF, BMP, or GIF. Once uploaded, the API will generate a unique identifier, store the file, and configure a web map service. What's returned is a JSON document containing both the web map service URL and the unique identifier that is used in later steps. So let's take a quick look at the format of this JSON response. We have a status key that will either contain success or fail. In the case where the status is anything other than success, there will be a message describing the error. There's the height and the width of the raw image that was uploaded. There is a unique identifier that is used in later steps, and a web map service URL with a layer name. The web map service is in a raw custom coordinate system. In other words, the raster location of x1, y1 is represented in the web map service as coordinates x1 and y1. This makes it very easy for any front end to collect pixel location based on coordinates clicked by an end user. So a web-based front end could easily add a base map and begin collecting GCPs from both the raw image and the base map. Once we have ground control points that match pixel coordinates to map coordinates, we can use the other features of the API, the root mean square error and the georeferencer. Let's start with the RMSE. This route expects an HTTP POST method, with the body of the request being a JSON document. Let's take a quick look at the format that the API expects. This JSON document can have any top-level key names that you like. This gives flexibility to front-end developers so they can track the GCPs in a way that works for them. Here they are shown as 1, 2, 3, 4, and 5, but the values of those keys must be a JSON object with 4 keys: row, call, lat, and long, with row and call representing the pixel coordinates of the row and column of the raw image, and lat and long representing the latitude and longitude in decimal degrees. This JSON can be uploaded to /API/RMSE/UUID. The UUID is the unique identifier that was returned during the upload process. The response is a JSON document that shows the error for each ground control point. Let's take a quick look at this response. We have a status key, in this case indicating success. We have the full root mean square error that is generated server side. And under the RMSE vals key, the label for each GCP is returned exactly as it was submitted to the API. And the observed as well as the predicted geocoordinates are presented in NAD83, so the error can be calculated in units of meters. The georeference route behaves very similarly and accepts the exact same input and is located at /API/georeference/ UUID. And again, this UUID, shown in brackets, represents the unique identifier that was returned during the upload process. Just like the RMSE route, the JSON is uploaded via a post method. Once the API receives the GCPs, it takes the raw image, translates it using the GCPs, creates a warped image, and adds the newly created warped image as a layer to the existing web map service. The response from the API is a JSON document that contains the new layer name. This new layer can be added to a user interface to give better feedback to the end user about the quality of the placement of their ground control points. This interaction between the user and the API can continue, with the user adding, deleting, or modifying points as the API continues translating and warping the image and presenting that information via WMS until the end user is happy with the result. Then the user can download the result of their labor. The download route is a simple GET request to /API/download and the unique identifier used in the previous requests. The response is the full resolution image that is now georeferenced and ready to use in any GIS application. And that is the full workflow for the interactive method of georeferencing. So let's talk about the one-step method. The one-step method is extremely simple. Its use case is when the end user already has their desired ground control points and simply needs to georeference a raw image. To use the one-step method, a post request is made to /API/georeference. The body of this request is form data containing both the non-georeferenced image and the GCP JSON. The response from the API is a fully georeferenced image. So now that we know how the API works, I'd like to show you a couple of examples that demonstrate how the API can be used in the real world. These examples will also give you a better understanding of the API by simply seeing it in action. The examples that I'm going to show you are in the Georeference API codebase. And this codebase is located at the EDAC GitHub organizational page located at github.com/EDAC. And there you can see many of our publicly available projects, including the Georeference API. I'm going to be showing you the examples in the front-end examples directory. As you can see, we have both an interactive and a one-step example. The interactive example is meant to demonstrate the interaction between the end user and the API, with the end user supplying non-geo-enabled image and ground control points, and the API responding with feedback for the end user in the form of errors for each GCP and a web map service. And this interaction with the user modifying, adding, or deleting ground control points and the API responding with updated errors and a web map service will go back and forth until the end user is happy with the result and can download their image. The one-step example is used to demonstrate the scripting capability of the API. This is especially useful in situations where ground control points are collected by some other means or dynamically created in restricted environments such as an online machine learning service. Let's take a look at the interactive directory. This might be surprising to you that the interactive directory just contains a single HTML file and a sample JPEG. But the fact that a user anywhere in the world with internet access and this HTML file can georeference images really shows not just the power, but the vast potential of this API. If we go back and we look at the one-step script, we'll see that this is made up of an Excel spreadsheet that contains ground control points and file names, and a Python script. This Python script reads these GCPs, and for each file name, associated file name, it will post the image and the ground control points to the API and save the resulting georeferenced image. So let's take a look at the interactive. Now, I've already downloaded and extracted this code to my local system, and we're going to start by opening this interactive HTML in Google Chrome. So before we can begin adding ground control points, we first have to upload a non-geo-enabled image, and that is what this form on the left is for. Now, I'm going to go ahead and choose the sample.jpg, but it could be any image you like. Let's review real quickly what will happen once I click this upload button. This image will be uploaded to the API. The API will catalog it. It will generate a unique identifier used in later steps, and it will create a web map service of the raw image. Once that web map service is returned to the client, we can then replace this panel with that web map. So I'm going to go ahead and do that now and click upload, and you'll see that we have a web map service of a non-geo-enabled image. And this is important because this coordinate system of this WMS service matches the pixel coordinates for this raster. So by clicking on a point in this web map service, we are actually choosing a row and column pixel coordinate from the image. Just to the right of it, we have a basic base map. And the opposite is true for this, where here if we click a coordinate, we are actually choosing an earth coordinate. So by combining the pixel coordinates with the earth coordinates, we are able to generate a ground control point. On the right-hand side, we have multiple controls that will show the errors of the ground control points, the full RMSE error. We have show GCPs, which is not interesting yet because we don't have any GCPs. And we have a download button that is grayed out because we have nothing to download yet. We also have this zoom to sample button, and this is specific to this image, sample image that is provided in the examples. So we don't have to root around all of New Mexico to test this out. So let's go ahead and add our first ground control point and see what happens. Okay, so I'm going to go ahead and just choose this bush here. Now, believe it or not, nothing's happened, and that's because we've not yet communicated with the API. And there's a reason for that. We have found in cases where, for example, the raw image is oriented south-north, and if we were to generate, and we can georeference with a single point, if we did that, what would happen is the image would be placed exactly upside down, and it would be very confusing to the user. So because of that, we are not going to request a web map service for previewing the warping until we have at least 3 points. You might also notice that the RMSE is saying to pick 3 more points, and that is because if you have 3 or less points in your GCP list, the RMSE will always be 0. So that is useless information to the end user, so we are not including it. So, but you could, if you wanted to generate your own front end, certainly you could show the end user whatever you would like. So I'm going to choose another point, and again, no communication with the server. And so I'm going to add a third point. Now we are finally going to communicate with the server. The server will receive our ground control points, and we will finally get a web map service returned. So I haven't clicked yet. So as soon as we click this, the result of our GCPs will warp the image over here. It will warp that image and present it as a web map service over here. So I'm going to click, and now we have a preview of our GCP results. And as you can see, we're pretty lucky in that this case, the plane was pretty level to the Earth, and so things kind of match up pretty well. But we want to add another point to demonstrate the RMSE capability. So I see up here, we're pretty far off. I can see that path is not lining up. So let's go ahead and add another point to pin that down. And I'm just going to choose this bush here and this bush here. And yeah, let's take a look. That looks pretty good. That's lighting up. And yeah, I'm happy with that. But the important thing is we can now see that when we added a fourth point, we communicated with the API and said, give me the RMSE for these GCPs. And so what it did is it created a transformation based on the GCPs provided, and then one at a time transformed using that polynomial to get a ground control point, or an Earth coordinate, and then that Earth coordinate is compared with where we initially wanted it to be. The result is the RMSE is delivered in meters. And this is important because if you had a project, let's say you were georeferencing very large images that covered a large amount of area, well, you would expect very large RMSE. Even if it was very good and all the points were just really super, you would still expect a significantly large RMSE because even the smallest change could be hundreds of meters. The exact opposite is true. If you were georeferencing tiny images, you would get very low root mean square error, but it doesn't necessarily mean that that's good. It just means that your meters are very small. So the RMSE has to be unique to the project that you're working within. All right, so I could continue, modifying and adding and deleting individual points until I was happy with the results. I could end up deleting ground control points, but the end result is this is a demo, so I'm just going to accept this as good. So I'm going to go ahead and click download, and I'm going to download this example, and we're going to open this up in QGIS. Okay, so I'm going to go ahead and add a base map just so we can see that it matches up, and we can see that we now have a fully georeferenced image ready for use in any GIS application using the interactive method. So now let's take a look at the one-step process. We've already covered the basic parts of the one-step script. We have an Excel file, a Python file, and some non-geo-enabled JPEGs. But let's actually take a look at the code. And as you can see, this is a URL that we're going to be posting our images and our GCPs to. We're going to create a folder, if it doesn't exist, an output folder. So we read in from the Excel file, and for each row, we're going to grab the file name and we're going to grab the GCPs. From there, we're going to build a form that we then post to the API, and the API, if it responds with a 200 meaning good, success, then we're going to save what is returned to the output folder. So before we do that, let's go ahead and grab the GCPs and the image that we used in our interactive mode. And I'm going to go ahead and open up the Excel file, and I'm going to add the GCPs that we just created. Of course, I also have to put in the name of the file, sample.jpg. This is the non-geo-enabled image. And I'm going to go ahead and save that. And I'm going to copy that non-geo-enabled sample.jpg into this example folder. So this is not just going to georeference these images, but it's going to georeference, using the GCPs that we just gathered, the sample image as well. So I'm going to go ahead and run that command. And so to do that, I have to go to Downloads, Georeference, Static, Front, One Step. Okay, and I'm going to simply run Python one step py, and you can see it immediately created an output folder, and it has posted this image to the server, and the server has responded with a fully georeferenced image, and we were able then to save that to that directory. So as these images get processed, you can see the capability of the one-step process to immediately georeference an image as long as you have the GCPs that are generated from an outside source. So let's go ahead and go back to QGIS. I'm going to go ahead and remove the sample JPEG found here. And I'm going to bring in all of those newly generated rasters that are found in the one-step output directory. So I'm just going to simply select all of these, and we can see that we were able to georeference all of these images using nothing more but the one-step process, and including the image that we just created GCPs for. So in closing, I would just like to thank once again all of the staff, the students, and the volunteers who have been and will continue working on this project. And of course, I'd like to thank once again the National Archives. Without their contribution, none of this would have been possible. So thank you.
All right, so I'm going to stop sharing my screen now, and I will hand it over to Hayes. If you have any questions, please do go ahead and ask them, or you can type it in the chat.
So any questions?
I'll ask a question, Hayes. This is
Okay.
Lisa. Explain to me, I haven't seen actually the one step of the API before. How is it taking the points that were already determined from the one image and applying it to those other images, right? Like, how does it know to step over?
So no, it was like a whole fresh process. So as long as you have GCPs and a non-geo-enabled image, then you can simply georeference it by posting both the GCPs and the non-geo-enabled image, the JPEG, and then it georeferences it. So it was a little confusing because we were using the example from an image we had just georeferenced, but actually this is the best use case for this is when you already have a catalog of GCPs, or in cases where you're generating the GCPs dynamically. In those cases, that's where you would use the one-step method.
Okay, so you had GCPs for each individual image already.
If you do have
Okay,
GCPs,
got it.
or if, say for example, you had some kind of machine learning that was doing edge matching, and I don't want to give too much away, Sue has some ideas, but in such a case where you are able to dynamically generate GCPs, you could then simply use the API even in a restricted environment where they wouldn't let you install Google or GDAL.
Got it. Thanks.
And Emiliana posted a question, will this video be available to the public? Will it be on the NARA site or on the GitHub site? For now, I just posted the link in the chat. The video is currently available on the EDAC YouTube channel.
It's did we right now? I think it's only by link, but we can make it publicly available just by changing that setting.
So Lance Tyson has a question: can the API handle different transformation methods?
Not yet. We do have right now. It cannot, but we plan on adding functionality in the future. For example, let's say you want to use thin spline, then we would be able to submit that. So currently, no, but that is part of the plan. Also, right now, as you saw, it uses only decimal degrees as its inputs. We also want to be able to make it so whatever base map coordinate system you're using, you could also use that as long as you specify to the API what coordinate system you are providing your GCPs in. But that's a good question. It's something we've thought about and something we'll continue to work on.
Lance, I don't know if you are asking for the transformation, like the first order polynomial or second order or a third order polynomial. Is that the thing you are asking, or Hayes just answer your question? I get.
If his question was the order of the polynomial, we just let Goodle handle that, or GDAL. Sorry, I pronounce it Goodle because that's the way we used to pronounce it. But we just let GDAL handle that. It automatically, based on the number of points. But that's interesting. We could, I guess, also allow people to choose their order. That would also be useful.
Mm-hmm. Yeah, so as of now, like he said, we use Buddha to decide, so if the user input more than, 3 points, I think 4, then it will be using first order polynomial. If they have more than 6 or 7, I think the default is 7, then it uses second order. If you has more than 10 points, it's gonna be using third order. Oh, if you are talking about similarity projective, it's basically I think the Buddha is actually using is all of them, because similarity or fine is more like like a first order, and then projective more like second order, third order. So it's actually using all of them.
Carol has a question. Can you talk about when is it expected to go live and how it will be accessed?
Well, the code is live in the sense that we are currently using it. That is the workflow we initially set up. And if you want to, once we have more imagery to georeference, right now I don't think there's any jobs available. But yeah, you can log in and help us georeference. Also, the code is available on GitHub, and if you guys need help setting up your own API, you can. Otherwise, we also have a system that is publicly available at api.historicalaerialphotos.org. So you can actually go to GitHub right now and download those examples and use them. They'll work for you right now.
All right, another question from Emiliano. You mentioned students and volunteers. Is there a place to find information on how to get involved or volunteer?
Yeah, we haven't really talked about that yet. With people doing remote teaching, we thought it would be a really good uh, time to open this up to the classrooms, but we actually haven't done that yet. Most of that is my fault, is that I'm still trying to get this ready for public consumption. So I don't think we've actually done any outreach as far as students and or anything like that.
Right. Yeah. Hazel is right. So we haven't done any outreach yet, but the plan is that in the third year of the project, like starting July this year, we are going to work with 2 universities, including UM and also New Mexico State University for teaching in the geography department. So we could use, incorporate this into their remote sensing classes, or GIS classes even. Just when they teaching about the concept about georeferencing, instead of using a desktop software, now we could use it with online web application. So that being said, a student even with a Chromebook, they could download this easily instead of using a desktop application. So yeah, so in year 3, this is one of the things we are trying to achieve.
Okay, any more questions or comments? Don't hear anything or don't see anything in the chat. So should we go ahead with our raffle and finish the talk soon, or
Yeah, sure. I don't know if
is there
anybody,
anything else that you want to add to Sue or Hayes?
Yeah, we're also accepting any code contributions too. So, if you want to fork our code and make your own submissions to the georeferencing API, we'd be happy to have your help. Excuse me.
right. Yeah, well, on top of that, also I want to, thank really our team here, especially Hayes, just for the code development. Really, really, great work. I also want to let you guys know that I know that in the audience there are quite a few people from state agencies, or from different city, or you're doing GIS work. So if you do have historical aerial photos that is in your I don't know, in your cabinets, or that has been there for a long time, you really want to get the data out, you could give the data to us, or you could just also scan them, and then also using our application to do the georeferencing, because it could help you, even if you don't have desktop application, this could help you really get productivity up, and then get all the data out, while we publish them. So if you have that type of data, please contact Sandeep, or anybody at EDAC. We can help you get the project started. Especially Sandeep, he's leading our scanning and georeferencing work, and also Lisa. So really, thank you guys.
Thank you, Sue.
Thank you, Natalie. Thank you for sharing with your divisions.
I do really see lots of compliments and congratulations. Great job, you guys, on the presentation and the project as well. So if no more questions or comments, let's go ahead and finish up our exciting event, the raffle. So like each week, I took the participant list from the chat and I put it in the Excel sheet, and we used a random number generator to get the results. So the first raffle item is a book So I believe the last remaining book, right, Carol, is the switching.
Yep, it's the last one.
So unfortunately, there's no choice anymore. So this is the book you're gonna get. It is switching from ArcGIS Map to ArcGIS Pro. So the winner is Sager Sheets. Hey Sager, I do see you're in the chat list. I don't know if you can hear.
Hey Sandeep, I'm here. Just took me a second to come off mute. Thank you.
Sure, congratulations. And I do have your email, so we'll reach out to you and then you can send us the mailing address and we'll mail it to you.
Thank you very much.
Thank you. And then the next item is $25 REI gift card, and the winner is Laura. Is that Laura Gleesner or a different Laura?
Yeah, only first name are there, right?
Yeah, I do see in the chat.
Hi, guys. That's me, Laura Gleesner.
Hi, Laura.
Congratulations.
Yeah, congratulations.
Hey, you earned it. This is a great project, and I'm glad that I was actually a part of this in the very beginning. And good job, Hayes and Sue.
Thank you.
Yeah, and thank you for the work that you did to get us going.
Mhm.
My pleasure. Good to see everybody.
See it here.
Yeah.
Yeah, so that's all we have. Thank you everyone for joining us each week and making this Geoseminar a success. We hope you enjoyed these talks and learned something new. And we'll see you soon.
Thank you.
Thank you.
And thank you, Carol, for putting together all the speakers and organizing this,
Thank
and
you.
Patty and other board members, whoever on the participant list. Thank you
Yeah.
all.
Worked out well. Thank you.
Thank you.
All right, guys, have a good one. Bye.
Bye.
I
Bye.
Thanks. See ya.